Okay. All right. So today's topic is waec-type exercises on bearings and distances. This is a very important topic in mathematics and is usually tested in your international exams. So we are going to deal with the topic today. Okay. And I'm Mr. Peter of Petra Science Tutors. Okay. So we need a little background on this topic before we'll deal with the waec-type exercises. Bearing, what does bearing mean? Bearing simply means direction. Bearing simply means direction. And bearings tell us the direction of any place measured from a given reference position. Bearings tell us the direction of any place measured from a given reference position. Okay, so that's it. Now, there are two ways of representing bearings. You must know that there are two ways we can express the direction of places. Okay, the first way is compass bearing. The second way is a three-figure bearing. Okay. Now, what are compass bearings? Compass bearings simply combine cardinal points with the acute angle made by a connecting line drawn from the reference position. Compass bearings are always measured from the nearest north or south. Compass bearings are always measured from the nearest north or south. Okay. So they are compass bearings. We combine those two definitions. It's simply that compass bearings are acute angles measured from the nearest north or south. For example, you can have north 27 degrees east or south 80 degrees west. So these are compass bearing representations. So these are compass bearings. These are compass bearings. North 27 degrees east. See, that's an acute angle there. An acute angle is an angle that is less than 90 degrees. And you have south 80 degrees west. Okay. So look at it. So look at these examples. If you look at these examples. Okay. So this is an example of compass bearing north 49 degrees east. So you see it's from north. From the north you move in. The angle is measured with respect to the north, from the north. Okay, it's not measured from the east because we will have an angle down here. We don't measure from the east. Instead, we measure from the north, or in this case, from the south. So look at the second example here. Excuse me. Second example here is measured from the south. So that's why we said compass bearings are always measured from the nearest north or south. So from the south here, the angle that is measured from south going this way, 70 degrees. So this line is south 70 degrees west because the line is between south and west, and this line here in this first diagram is between north and east, so it's north 49 degrees east. Okay, that's right. So compass bearings are always measured from the nearest north to south. Okay, further examples, if you look at this, you can see should be north. This line is north 30 degrees east because it's between north and east, and the angle here is closer to the north. Okay, it's measured closest to the north. Okay, and this is also measured closest to the north. So this is another example of north. This is north 56 degrees east. Right? Okay. All right. So, example, your own practice. This is exercise for you. What compass bearing are shown in these diagrams? What compass bearings do you think are shown in these diagrams? Yes. Okay. So you can see this is the answers are south 30 degrees east and south 40 degrees west. The second way we can represent bearings is the three-figure bearings. Okay, it's also called three-digit bearings. It's also called the true bearing because this is the most commonly used bearing representation for bearings. So three-figure bearings use the three-digit values of angles which have been measured clockwise from the north. Three-figure bearings use the three-digit values of angles which have been measured clockwise from the north. Okay, kind of bearings. Okay, so in summary, three-figure bearings are always counted from the north and always counted clockwise and are always three-digit values. So let's look at some waec-type questions. Number one, express the true bearing of 250 degrees as a compass bearing. express the true bearing of 250 degrees as a compass bearing. So you can sketch it. You can sketch it. You can see 250 degrees is likely going to be in the 250 degrees. You find that in, is it in the first or the second or the third or fourth quadrant? You're likely going to find it. You're going to find it in the third quadrant, because third quadrant is between, recall, is between 180 and 270 degrees. This value of 250 is between 180 and 270 degrees. Okay, so the answer is D. The answer is D, south 70 degrees west. All right, because 180 plus the value that will give us 250 degrees. So 180 plus 180 subtracted from 250 is simply 70 degrees. So this south 70 degrees west is the correct answer for question 1. For question 2, the bearing of south 40 degrees east is the same as the bearing south 40 degrees east is the same as, okay, so now compass bearing to 3-figure bearing. South 40 degrees east is in the second quadrant. This is the second quadrant, 40 degrees, because this is in the second quadrant. Second quadrant has to be greater than 90 degrees in 3-figure language. So 90 plus the complement of 40. The complement of 40 degrees is 50. Okay, because 90 plus 50 will give us 140 degrees. Okay. You can easily sketch that to be able to know. You sketch it to be able to get the picture of how we came to these answers. So let's proceed. Okay, so let's look at the steps we need to follow when solving bearings and distances. So step 1, identify the reference position. Step 1 is to identify the reference position. Remember our reference position identified. You just have it, put a dot and a plus sign should be placed on the dot. Okay, I call it a plus sign or a cross. Okay, so the first step is to identify the reference position. That's where we're measuring from. Okay. Second step is to draw a line to the appropriate quadrants of the reference position to a second or third position, taking note of any alternate angles between the two or three positions. Okay, so when we do an example to make these steps clearer, step 3 is optional. Okay, step 3 is optional because we might be asked to find the distance between 2 points. But if it's just purely bearings, then this step 3 is not necessary. But if it is bearings and distances, if distances are involved, step 3 is important. So finally connect all the positions. Step 3 says we have to finally connect all the positions with straight lines to obtain a triangle which can then be solved using our knowledge of geometry. So connect all the straight line so that it forms a triangle which we can solve with our knowledge of geometry or trigonometry. Okay, so let's look at an example to be able to apply. Let's do this. If the bearing of a point B from another point A is 245 degrees, what is the bearing of A from B? If the bearing of a point B from another point A is 245 degrees, what is the bearing of A from B? So the hint is that you must know where you are measuring from. The bearing is measured from where? So the key word is from. So from tells us where we are going to put our first dots and cross. The from tells us where we are going to be measuring from, right? So let's see how that's done. So the question says from the bearing of a point B from another point A. So from where? Another point A. So our first reference position should be point what? A. Because we have from where? From A. So we have to identify point A, and that's what you have here. You can see point A has been identified with a dot and a cross or a plus sign. The dot is there, and then we have the letter is, the position is identified with an alphabet. So A, and then we have a cross or a plus sign. And it said, the question says the first reference point is at A, 245 degrees. So from point A, point B is on a bearing of 245 degrees, right? So 245 degrees, if you are measuring that from north, you go round and round. You see the red arrow there, goes round and round, 90, first quadrant, second quadrant, 180 degrees. Then the third quadrant is not completed. it's not up to 270, so we stop at 245. Now 180 plus what will give you 245. That's important for you to calculate. 180 taken away from 245 gives us 65 degrees. Okay, and our step says we should take note of alternate angles. So this is the first reference point. So where that 245 stops, where 245 stops, you draw a line. So we draw this, see this blue dotted line, draw a line to another dot. So this dot is going to represent the second position, B in this case. Put a dot and put a cross or a plus sign, or place it on top of the dots. Okay, so that we can see those quadrants. So this is the connecting line. This is what the connecting line. So it's this line that we use to read the bearing of points from each other. So B is bearing of B from A is 245 degrees as given in the question. Now, this question now says, what is the bearing of A from B? So this is an example of what we call back bearing or reverse bearing. So measured from A, point B is on bearing of 245 degrees. But the question now says measured from B, what is the bearing of point A? So you can see if the three-figure bearing says, you see the line. So read the line. Read the line. Reading the line, you can see the angle that has been covered from north, because three-figure bearings are always measured from north. From the north, this due north arrow here goes down and stops here, because that's the connecting line between the 2 points of interest. So what angle has been covered? 65 degrees. So as a 3-digit bearing, the answer is 065 degrees. Okay, because we know that these are alternate angles. Remember, these are Z angles, like the Z angles. Okay, so the next question says the bearing of a point Q from another point P is 310 degrees. What is the bearing of P from Q? So this is another example of reverse bearing or back bearing that we just saw. The answer is what we have here. So that's the diagram there. So from point Q, 310 degrees is actually in the fourth quadrant. So 90, coming from north, 90, 180, that's 180, goes again, 270, till we get to 310 degrees, we don't stop. So we have that, we go round around 90, 180, 270, and finally, this little angle, the bearing of P from Q. Remember, we started from P. Starting from P, see the dot and the cross. Starting from P, you see that point Q is on a bearing of 310 degrees. It has gone round. It has gone round to give us 310 degrees. So to the second dot Q. So dot Q now is going to measure point P from itself. So from point Q, this line, this connecting line, you see, the connecting line is important. The connecting line is where we are going to stop our journey at. So coming from north, because it's three-figure bearing we are talking now, we're not talking compass bearings. Take note, boys and girls. So we have that from the north. If you travel till we get to this connecting line, if this arrow due north was to travel till we get to the connecting line, what is the value of the angle it has traveled? You see, it has traveled from, it has covered a quadrant of 90. So 90 plus what? You can see this should be Z angle. This is an alternate angle of 40. If this is 40 here, it's not written, it's 40, then here should be 40 also. So 90 plus 40 gives us 130 degrees. So our answer is 130 degrees. Thus, the bearing of point Q, the bearing of point P from point Q is 130 degrees.